So here, of course, we have a perfectly inelastic collision. And we know that the conservation of angular momentum applies. So we can say I sub 1 omega sub 1 equals I sub 2 omega sub 2. We're trying to find the final angular velocity. So omega sub 2 would equal I sub 1, the moment of inertia initially, times the initial angular velocity, divided by the final moment of inertia. So this could be equal to omega initial times the moment of inertia of the merry-go-round, divided by the moment of inertia of the merry-go-round, plus the moment of inertia of the people on top of the merry-go-round. And so this could be equal to omega initial of I sub merry-go-round divided by I sub merry-go-round plus here we'll have 4 people times the mass of 1 person times the radius of the merry-go-round squared. And so we find that omega sub 2 equals 0.80 radians per second times 1360. And then for the denominator, 1360 plus 4 times 65 times 2.1 squared. And so this will be equal to 0.434 radians per second. So this will be your final answer for part A. And then for part B, they're asking us if the people were on initially and jumped off radially. So people were on a merry-go-round initially, jumped off radially, this would mean that the change in angular momentum equals 0. Because they're jumping off radially, they're not changing the angular momentum in any way, which means that the omega final would simply equal omega initial. And again, this would equal 0.80 radians per second. So this would be your final answer for part B. That is the end of the solution. Thank you for watching.